So welcome to lesson 2 in measurement. Today we're going to talk about area, and we're going to talk about the area of a rectangle, an area of a square, area of triangle, parallelograms, and trapeziums. Now, area of a circle will be covered in another lesson where we talk about everything that's related to a circle. So in the last lesson we defined what perimeter was, and it is the distance around a shape. So now we're going to talk about the area of a shape, and this is the size of the surface of that shape, which is surrounded by the perimeter. Now it sounds like a lot to remember, but it is the area, it is the surface inside of that perimeter. Okay, so here in this shape below we have the perimeter, right? So it's going around the shape, perimeter, and the green inside is the area. Okay, so the area is the surface on the inside of that perimeter. Now the metric unit, remember we talked about SI units. The metric or SI unit of area is meters squared. Right? Larger areas are measured in kilometers squared. Okay, and we write it as we see it here, right? Kilometer, km, and a superscript of 2. Right? So this tells us when something is squared, multiplied by itself. Smaller areas are measured in centimeters squared or millimeters squared. So these are the 3 common units that we will see in maths and in physics or any other science subject, right? Now, we learned in the last lesson that 1 meter is equal to 100 centimeters. Now, if we want 1 meter squared, we are going to square that 100. So 1 meter squared is just 100 centimeters squared. Alright, so we multiply 100 by itself. 1 centimeter is 10 millimeters. We learned this in the last lesson. Now, if we want 1 centimeter squared in millimeters, we will square that 10. So 10 multiplied by 10 will give me 100 millimeters squared. Okay. 1 kilometer we learned in the last lesson is 1,000 meters. 1 kilometer squared is that 1,000 meters squared. So 1,000 by 1,000 is equal to 1 million. So 1 kilometer squared is equal to 1 million meters squared. And we could do a nice little chart like what we did. Alright, so if you have this chart you can put on your cue card, right? You know those cards that students, index cards, right? Or cue cards that they like to write the formulas on to help them revise. This is something you could put on that, or you could write it in your maths formula book if you have a dedicated notebook or copybook just to write all the formulas and your definitions in. Alright, so if we want to go from kilometers squared to meters squared, what would we do? We would take that, we know that 1,000 kilometers is 1 meter squared. Okay, but it's not kilometers to meters, it's kilometers squared to meters. So it's 1,000 squared. Okay, and that will give us 1 million. Okay, so we multiply by 1,000 squared. If we wanted to go from meters squared to centimeters squared, we saw that 1 meter is 100 centimeters. So we would multiply by 100 squared, which is 10,000. We wanted to go from centimeters squared to millimeters squared, we know that 1 centimeter is 10 millimeters. So we would multiply by 10 millimeters squared, which is 1,000. Alright. Now when we want to go from millimeters squared to centimeters squared, we will do the opposite. We will divide by that 10 squared, which is 1,000. If we wanted to go from centimeters squared to meters squared, we will divide the centimeters by 100 squared or 10,000. If we wanted to go from meters squared to kilometers squared, we divide by 1,000 squared, which is 1 million. Okay. So remember to pause the video and take down the notes, these extra writings and these extra notes in your own copy of this, okay? Now we're going to look at finding areas of shapes when it's on graph paper, okay, or on a grid. So let's find the area of A. Now no scale is given for the graph, alright, there is no centimeters, there is no meters, there's no kilometers. So in this case we use units squared, alright, as our unit of measure. So when it's on a graph, it's a little bit easier. We could count the blocks. And if it's a regular shape like a rectangle or a square, it's easy to count a whole number of little squares. So here we have 1, 2, 3, 4, 5, 6 little squares that make up the area, right, of this shape. So we would write that as 6 units squared. Okay, so you could put that little superscript up there. Now let's find the area of B, which is an irregular shape. Now first thing we would do is, so your steps for irregular shapes. So we have a regular shape here and an irregular shape. Okay, that's an R. So your steps will be 1. We would count all the whole squares. And then 2, count the pieces and make holes. Now not H-O-L-E-S, right? We don't want holes in the paper. We want W-H-O-L-E-S, whole squares. Right? The third step would be add the squares from steps 1 and 2. Okay, so let's do that. Let's count all the whole squares first. We have 1, 2, 3, 4 whole squares. Okay, and then let's count up the pieces now to make holes. Now this piece here looks like a half and this piece looks like another half. So these two here could make one more square. Now look at these little pieces. Alright, it might take 1, 2, 3 pieces to make one hole again. Okay, so that's another hole there. And then we could pull this little piece into, right? So we have these 4 pieces making one hole. As you could see, if we look at the shape of the square, half of a square might be somewhere here. Alright, a half of the square might be here where this yellow line is. Now, if we look where the green shaded part is, it is less than half. It's actually half of the half, which is a quarter. So we could add these little pieces here and these 3 pieces to make one whole shape. Okay. Now, on the other side, we have some pieces here. So we could use these 4 pieces here to make another whole. That is this piece, that piece, and this. Okay, including this little piece here as well. So that's another whole. So now step 3 says to add what we get from step 1 and step 2. Okay. This is a 1 here. Alright, so this is one whole here. So let's add them up. We have 4, 5, 6, 7. So 7 units squared. Alright, and this is how we find the areas of irregular shapes when it's on graph paper. Okay, so here in this section, let's give each square an area of 1 centimeter squared. So what this means is that the area of these little squares here on your graph paper, use one here, right? This little one here. This is 1 centimeter square. 1 centimeter multiplied by 1 centimeter. Okay, it's a square, so all the sides is 1 centimeter. Now the area of this one little square they're saying here is 1 centimeter squared. Okay, 1 multiplied by 1 will give us 1. Now here, they did tell us the units. Unlike the first part, where the unit here, we didn't know what the unit was, so we just said units squared. But now we do know what the unit of measurement is. So instead of writing unit squared, we would write 6 centimeters squared, 7 centimeters squared. Alright. Now, you pause the video and try to find the areas of these shapes here. Now, I didn't say what units of measurement we're using here, so I would like for you to use units squared. Alright, so pause, find the area of these, and then unpause and check your answer. Alright, so I hope you pause and try these. Now, area of A. So this is a fairly regular enough shape. It's made up of a square and a square. So we have 1, 2, 3, 4, 5. Alright, so 5 units squared there. The area of B, we have 1 whole square. And then we have 2 halves. And 2 halves make a whole. So we have 2 units squared for the area of B. And C is 1, 2, 3. And we could use these 2 here to make another 1. And then we could use, let's see, these 4 pieces here to make another 1. And we could use these 4 pieces here to make another 1. So we have 3, 4, 5, 6. That's 6 units squared. Alright, so we have 6 units squared here for this irregular shape at the bottom. Now we have a nice practical activity here. Now this is an experiment that you would be doing in physics if you're doing the sciences, and some teachers might let you do it in maths. Alright, but it's a fun exercise and I would really like for you to try it. So what you would do is get a sheet of graph paper, put your shoe or your foot on the graph paper, and with a dark pen or a marker, draw around the outline of your foot or shoe. And then using those little squares on the graph paper, just like we did how we found the area for irregular objects, For irregular shapes, I want you to count the squares and find the approximate area of your foot or shoe. Alright, so you could try this activity with your family members or with friends around your age and compare. Who has the biggest foot, right? We could find it by looking at the area of their feet. Alright, so you can repeat this activity as well using your hands. Alright, now let's look at the area of rectangles. We know that rectangles are four-sided shapes where two sides are longer and equal in length, and two sides are shorter and equal in length as well. So let's consider the following rectangle. Now the purple part inside is the area that we want to find. The longer side of the rectangle, we call it the length, and the shorter side, we call it the width or the breadth. Now the area of the rectangle A is, and we use this formula, area is equal to length multiplied by the width or the breadth. Okay, if we were using letters, it would be L by W, which is the same as L by B, right, where B is the breadth. So any one of these could work. Alright, the main thing is to be consistent. We don't want to be using the length for the width and the width for the length. Okay, we can't interchange those, but we could interchange or switch around the words width and breadth. Now, if they gave us the area and the length and we need to find the width, how can we do that? So that is, they gave me A, they gave me the length, but they didn't give me the width. And I need to find what the width is. What we will do is the opposite of what is happening here. The width will now be equal to the area divided by the length. Alright, so on this side we're multiplying by the length. And when we carry the length across to the other side of the equal sign, we do the opposite, we divide. So the width is equal to the area divided by the length. Alright, and this is another formula for you to learn. Or you just learn to rearrange it. Now if they gave us the area and the width and we need to find the length. So they gave us the area and we have the width and we need to find the length. Again, we would do the same thing as before. We would carry the width on the other side. And because we are multiplying by the width, we do the opposite. We will divide by the width here. And that will give us the length. So the length is equal to the area divided by the width. Alright, so let's look at some examples here. We need to find the area of these shapes. Alright, so we're going to find the areas. Oops, I joined the word. Alright, the areas of A and B. Alright, so we know that the area is the formula length multiplied by the width. Same thing as here, area is length by width. Now my length is the longer side, so that's here. My width is going to be the shorter side. And in B, the length is going to be the longer side, and the width is going to be the shorter side. Now pause the video and find the areas of these two, and then unpause and check your answer. Alright, so hopefully you paused and you tried them. Now I'm going to substitute in these values for my length and my width. My length is 7.5 centimeters. My width is 3 centimeters. So my answer should be 7.5 multiplied by 3 will give me 22.5, and my units are, remember we have centimeters by centimeters, so it's centimeters squared. On the other side, for B, we have the length as being 6.8 centimeters and the width being 5 centimeters. Okay, and our answer should be 34 centimeters squared. Alright, so our area is always some unit squared. Right, so we have a nice table here where we get to use the formulas on the other page, alright, these here, and apply it to find the lengths, the width, and the areas of these things. So pause the video, try this for yourself, and then come back and check the answer. Alright, so hopefully you give that a try. So our area is length by width, which is 12 multiplied by 4, which is 48. Now here, because we already have centimeters squared in our table, we don't need to go back and write centimeters squared. Alright, it's not advisable. If you're doing an experiment in school, if you have a table and you have the units in your heading, you don't need to go back and write the units again. Okay, it's taken care of in the header of your table. So for this one, our area again is the length multiplied by the width. So that's 24 multiplied by 6, and that will give me 144. Now in this case we have the area and the width, and we need to find the length. So on the previous page we said that to find the length, it's the area divided by the width. That's 126 divided by 7, and that will give me 18 centimeters. Similarly, to find the width, we would take the area and divide it by the length. That's 279 divided by 31, and that's 9. Okay, and the last one, 4.5 by 3.2, because it's just length multiplied by width to give us this area of 14.4. Right, so those are your answers to this question. Alright, example 2. Abby has a rectangular shaped lawn with a width of 5.3 meters and a length of 8.7 meters. Calculate the area of the lawn. So this one does not have a diagram to go with it. If you can't visualize or see what is happening here, that this is the L and this is the width, quickly draw a rectangle, and put in your length 8.7 meters and 5.3 meters. Okay, and the area is what we want. So always write your formula. Area is length times width. You could use the symbols, you could write out the words. Alright, always put your formula when you're doing a question. The reason for this is, if you make a mistake with your calculation, if you multiplied wrong, your teacher or the examiner will know that you know what you are doing. Alright, so they know that you know the area is 8.7 by 5.3, and then you put your final answer at the bottom. Okay, so it's always good, whatever subject you're doing and you have calculations, you write your formulas. Okay, sometimes you actually get marks for doing that. Alright, in the science subjects, you get marks for writing those formulas. So this is for 46.11 meters squared. Okay, because it's meters multiplied by meters. So this should probably be revision for you, because this was covered in SEA. Okay, or common entrance. Way back in the days, we wrote something in Trinidad called common entrance exam. Alright, and we would learn this in primary school. So this might be a little revision for you. Now, squares are four-sided shapes where all four sides are equal in length. Alright, so the area for a square, right, so the area of a square here, we wouldn't use length times width. We would use something called side by side, or we could say side squared, and we write it as S squared. Okay, so your area here is still the capital letter E. Alright, now here we have this side. As you could see, all the sides in a square are the same length. So the area here is side squared or side multiplied by side. And in this case, it is 2 centimeters multiplied by 2 centimeters, which will give me 4 centimeters squared. Okay, so let's look at the area of a triangle. Now, the area of a triangle is given by base multiplied by perpendicular, height, and all that divided by 2. Alright, so this is your formula. And if we wanted to use symbols, we would use capital A for area, B for base, H for height, and divided by 2. Let's look at this example here, and we'll see why it is divided by 2. Now, I could use this length here, AB, or I could use BC to be my base or my height. So here could be my base or my height. If I flip this rectangle 90 degrees, this could be my base or my height. The most important thing is to look to see where they are forming 90 degrees. Okay, so we know a right angle forms a 90-degree angle. And if I were to just multiply base by height, what would I get? Look at the shape, the entire shape. If I were to multiply just the base by the height, I would actually be getting the area of this entire rectangle, right? So, when we divide by 2, we're actually getting this triangle, what we want, this shaded part. So that's why we divide by 2. Because if we just multiply the base by the perpendicular height, we would be getting the entire area of a rectangle or square. Alright? But because it's the area of the triangle we want, we're going to halve that. And that's how they came up with this base multiplied by height divided by 2. Now, it's not any old height, it needs to be a perpendicular height. And we'll look at some more examples below on the next page. So let's work this out. In this case, my area is my base, which is 7 centimeters, multiplied by my height here, 4 meters. Now be careful, this is 4 meters. Alright, we need to change one of these to the other. Alright, we can't have centimeters multiplying by meters. So let's change the 4 meters to centimeters. Alright, 1 meter we know is 100 centimeters. So 4 meters is going to be equal to 4 by 100, which is 400 centimeters. Okay, so what we're really multiplying here now is 7 centimeters by 400 centimeters. We need to have the same units there. And of course, don't forget divided by 2. We are dividing this by 2. Right? So 7 fours are 28 with 2 zeros and divide that by 2. Our area of our triangle is 1400 centimeters squared. Alright. If the question specifically says put it into meters squared, then you would change this back into meters squared. Alright. So that is how they came up with this formula here. So this is your formula to learn for the area of a triangle. Now let's take a closer look at that perpendicular height. Now this is very important. Okay. You will come across this finding the height of triangles later on and in other subjects as well. So you need to understand where this perpendicular height is. So let's look at A. Here is my base and my height must be at right angles to the base. So if a triangle is shaped like this dotted line is where your height is. Alright, so it's base multiplied by the length of this height. Right, so this is a h. Looking like a little n, but it's a h, right? For height. So look at B. This is my base and my height will be perpendicular. Now if they had given this as the base, then we would look to make a perpendicular height this way. Okay, so wherever they choose to be the base, you need to look for where that perpendicular height is. Now here is the base and the perpendicular height is from here to the top here. It's actually on the outside. Okay, so you would need to find this height before we could find the area of this shape. Now there are other ways to find the areas of these shapes, but that is not covered until Form 4 or Form 5. Alright. For now, you just need to know how to identify where the height is in these triangles. Okay, so you can take a look at these and look at these notes should you get any triangle and you need to know where the height would be. So I'm going to do some examples here. I will just make this smaller so I can reference these triangles above. Calculate the areas of these triangles. Now, we see in a nice right angle here. Okay, I could use this as my base and this is my height. Alright, these two sides here are perpendicular to each other. So my area is length. Area is not length. Area is base by height divided by 2. And that is 7 multiplied by 3 divided by 2. So that is 21 divided by 2, which is it should be 10.5, right? And your units is centimeters by centimeters, so it's centimeters squared. So let's look at B. B is, we are seeing a right angle being formed here, and we have these two sides. So the area is base multiplied by height divided by 2. 8 multiplied by 9, or 9 multiplied by 8 will be the same thing, and divided by 2. Okay. So make sure to pause these videos and take down all your notes. Try it yourself. Alright, we have 36 centimeters squared because our units was centimeters. Alright, so in this case here, they gave us the area of the triangle, and we need to find the value of x. Now, x is going to be our height. Alright, so this is going to be my base, and this x is my height. And they gave me the area already. So we know that area is base multiplied by the height, or in this case, let's use x. Let's use what they gave us. Base multiplied by x. Now notice how I write my x for multiplication and my x for the unknown differently. And this is going to be divided by 2. So we know what the area is. It's 29.4 centimeters squared. We know what the base is. It's 8.4 centimeters. And we don't know what x is. And we have divided by 2. Now, let's move what we know across to the other side. If I am dividing by 2 here, and I want to bring this to the other side of the equal sign, I will do the opposite, which is not divide, but to multiply. Alright, so I got rid of that 2. So now I'm left with 8.4 multiplied by x. Let's work this out. 29.4 multiplied by 2. And that gives me 58.8. Okay. Now I need to move this 8.4 across to the other side so that I'm just left with x on this side. Now if I'm multiplying by 8.4 on the right hand side here, when I bring it across the left hand side, I will do the opposite, which is the opposite of multiply is to divide. And I'm left with the x. So now we have 58.8 being divided by 8.4, and that will give me 7. So my x here is 7, but it's not just 7. Okay, it's 7 centimeters. So we need to write that x is equal to 7 centimeters. Now let's find the area of a parallelogram. A parallelogram is a four-sided shape with 2 pairs of parallel sides. So our first pair is this side here. I'm going to call this A and A. And the second pair is this B and this B. Okay, and they're parallel because if I were to extend these lines that are parallel to each other, they will never ever touch or meet. Okay, they would never converge at one point. Okay, so that's why they're parallel. The same goes for the two sides with A. If I were to extend these, the two yellow lines will never meet because they are parallel to each other. Now, a parallelogram with a base B, so here we have something else. We have a base B here, so this is our base, and a vertical height of h. Now, this height must be perpendicular. Do you see? If I extend this line, I'm forming a 90-degree angle here. Alright, this is my height. Now, a parallelogram is made up of two identical triangles. So the entire shape is two triangles put together. And our area is just simply going to be base multiplied by height. Now we're not going to divide by 2 because we want the whole thing, right? We don't want half of that shape. We want the whole thing. So it's just simply base multiplied by height. Now, one more addition to that. It's going to be the perpendicular height. Not any old height that we find in that shape, right? It must be perpendicular to. Okay? So B by H is my area of my parallelogram. Okay. So if we look at these diagrams here, they tell you where the height is. And if you notice that the height is right angles to, or 90 degrees to, the base. Alright, so here is my base. This 5 cm is my height. This is my base. Did you see that they form a right angle here? This is my height. Okay, and it's similar to the triangles we looked at above, the different shapes of triangles, and we looked at where the height was. Okay, so here is my height. This is my base. My height is here, and my base. Now pause this video and work out the areas of A, B, C, and D. And then unpause and come back and look at the answers. Alright, so hopefully you paused and you did the questions and you got these answers. So the area of A is 30 centimeters squared. Your units are important. If you get your units wrong, you could have the possibility of losing the whole mark for that question. Alright, for your answers. So B is 21 centimeters squared. C is 32 centimeters squared. And D is 26.98 centimeters squared. Okay. At any point in time, if you didn't get these answers and you want further explanation, feel free to message me. Alright. So let's look on the other page. Okay, so we have another A, B, C. I will do A for you, and then I would like for you to pause and try B and C, and then look at the answers. So this parallelogram has an area of 48 centimeters squared. So here they gave me the area. Alright, so I know my area is base by height. What is its vertical height if its base length is, and A is 6? So I know my area is 48 centimeters squared. They told me that my height is 6 cm for part A, and I need to find the base. Now for the other questions, when we wanted to find the unknown, we carried all that we know to the other side of the equal sign. So my base here is being multiplied by 6. So if I take this 6 to the other side of the equal sign, it's going to do the opposite. It's not going to multiply, it's going to divide. Okay, so now my base is 48 divided by 6, and that gives me 8. So my base is 8 centimeters. Alright. Now you try B and C. Pause the video, try B and C, and then come back and check your answer. Okay, so now that you've paused the video and tried these, our answer for B is 6 centimeters. Now notice how I wrote the formula, I substituted my values, and I showed my working how I got my base. Okay, I did the same thing for C. I wrote my formula, substituted, found my answer for B. Okay, and this is the pattern you should take when you're doing all your maths questions. Even though you probably could work it out mentally, still write some working. Alright. Alright, so let's look at the area of a trapezium. Now, a trapezium has only one pair of parallel sides. As we can see, A and B here are our parallel sides. If we extend these lines, they will never meet. But if we look at the other two sides here, if I extend these lines, they will meet at some point in time. So those two sides are not the parallel ones. It's important to know which two sides are the parallel sides, because your formula is A plus B divided by 2, and that is then multiplied by the perpendicular height. Okay, so I'm going to put the multiplication sign by the perpendicular height. Alright, it could also look like this: A plus B over 2 by height. You just need to know that this is being multiplied there. Okay, you could also write a half A plus B multiplied by height. A multiplied is implied between the brackets and the H. Okay, if you want to write a half multiplied by A plus B multiplied by height, all that is fine. Okay, so your two sides, your A and your B, are the parallel sides. Right? Your H is the perpendicular height. Now, looking at this diagram here, your H could also be here. As long as you have a right angle there being formed, your H could also be here. Alright. We could also split this shape here into two right angle triangles and a rectangle or a square. Okay? Or a square and a right angle triangle. So let's look at these examples at the bottom. Here we could have two triangles. Okay, that rectangle in the middle. Okay, so if you wanted, you could have found the area of these two triangles and the rectangle and add them, or we use the formula. So our formula, our area, is equal to half of the sum of our A and our B, A plus B, multiplied by the height, right? Perpendicular height. So again, write your formula and then substitute in your value. So this is a half of 9.4 plus 5.6, and then we multiply by 6.3. So that is 7.5. This part here is the 7.5, and you're going to multiply that by 6.3, 47.25, and the area is centimeters squared. Now let's look at B. First, we identify what is our parallel sides, and we could call them A and B. It doesn't matter which one you call A, which one you call B, because when we add them in any order, it's still going to give us the same answer. Okay, our height is this one, and not the 10, but the 8. Okay, because it's perpendicular to the parallel sides. So again, we write our formula: a half of A plus B multiplied by the height. That's a half of 27 plus 15 multiplied by 8. So 27 plus 15 divided by 2, that will give me 21, and then I'm multiplying that by 8 to give me 168 centimeters squared. Now part C, my perpendicular line is going to be here, this 8 centimeters and not this 10. My two sides would be here A and 14, which is B. So my area is a half of my A plus B multiplied by the perpendicular height. That's a half of 8 plus 14 multiplied by 8. So let's look at this part. 14 plus 8 or 8 plus 14 is the same thing. And then divide that by 2 will give me 11. 11 multiplied by this 8 is 88 centimeters squared. Alright, now all our units here were the same. There was no meters mixed with centimeters, so it was pretty easy to do. But you need to pay attention to your units. You need to look out and make sure that they are both the same before you multiply, or add, or subtract, or divide. Right? Now, again, we said there are other ways to find the area of a triangle, and you would learn those in Form 4. So, this is the end of this lesson for areas at this level, and we still have to cover the perimeter of a circle and the area of a circle, but we'll do that in another lesson, so we can do everything about the circle in one lesson. Alright? And we'll look at the parts of the circle as well. Make sure you have all your notes and try the activity that will be accompanying this lesson. And I'll see you in the next video.